On this side of our guest room network area, we actually have what we consider the future of our guest room network design. This is actually fiber to the room, and like it sounds like, we're actually running a fiber optic cable from the computer room in the basement up through the IDF closet, and then horizontally that fiber goes all the way to the guest room. And what that allows us to do is obviously go long distances over fiber optic, but it also allows a great amount of bandwidth. As the world progresses and bandwidth curve continues to go up, we feel that the copper horizontal will limit us in the future from delivering all the bandwidth that we need and our guest rooms will need. There are technologies that are approaching 4K televisions, immersive gaming, and obviously the guest bandwidth needs probably at the forefront of that continue to grow with multiple devices and laptops and tablets and phones, et cetera, all riding atop our infrastructure to get out. So we feel that in a fairly short time that the need for the guest room to be able to support over a gigabit of connectivity to the guest room will be there, and the fiber optic cable allows us to get to that point and surpass it quite easily. So what we have here is a guest room network. This is the guest room IDF closet, still being fed from our network core switch area on the other side of our room here. This is a typical guest room floor. Could be in a resort environment, could be in a tower hotel. And then horizontally, this is our second floor. We have 201, 202, and 203 as our guest rooms. And each room would have in it a fiber optic handoff, and that leads into a fiber-fed switch. This is using a technology called GPON, which is the same technology that they use for fiber to the home technology. It's like FiOS in Verizon's world here in the U.S. And this is a GPON endpoint. It turns the fiber optic cable into an active network connection, and we have the connectivity onto copper to get up to the access point, the phones, the set-top box. One of the beauty of this is it's the same design, whether it's a tower hotel where we have the same componentry feeding a hotel, or in a resort environment where distances may come into play. Typically in a typical design in a resort environment, you may have a completely different design to support long distance technologies. Here we're actually showing 12 or 20 kilometers of fiber optic cable feeding a guest room that might be in a villa. Obviously that's probably extended than we would in the real world, but it's just showing that there is no distance limitation as far as building one of our resorts, that we can go from one side of an island to another to feed a set of villas or a single villa area. And so from that switch we're feeding the access point, phones, set-top box. We're also working here on an extended power design, so we're actually feeding power from the main hotel computer room up through the IDF closet passively with no electronics, and then horizontally into the guest room environment. We're feeding that long distance DC power plant to allow the devices to stay up and operational, and which will obviously in turn the phones and access point will continue to operate those devices during an extended power outage. So it meets the same goals as our hotel, the copper cable plant, but also allows us to have long distances and extended amount of bandwidth or enhanced amount of bandwidth to feed the hotel. Well, the beauty of this system is not only obviously that it's all read on fiber, but actually that our IDF closets have become completely passive. So over on the copper side of the room, where we had a lot of active equipment, both switches, and needed a generator circuit and a UPS to keep that room up and running during a power outage or just to keep it operational. Here on this side, the IDF closet is completely passive. There's no blinking lights or anything plugged in. And so from a construction development standpoint, we need a much smaller footprint in this IDF closet. We don't need to ask for generator circuit or UPS circuit to feed this electronics. It's really completely a passive pass-through environment. And that will allow these closets, the endpoints, come all the way to the endpoint and are powering both the devices from far off. And that allows us obviously a much lower cost on development, but also we were able to more or less individually operate the room from the main computer room facility of the hotel. So in our fiber to the room environment, we actually have several things going on here. Just wanted to explain. So we have a fiber optic cable coming into the room. This is coming from the IDF closet, where it's passing through an optical splitter and distributed to every room on the floor or in a villa set. And in that, so that fiber comes in. What we're doing is actually providing multiple strands of fiber. As you'll see here, we have 4 strands of fiber feeding the guest room. Only one of them is currently active to power up the optical network switch. But what this does is this allows us some flexibility from an infrastructure standpoint, that if there's new technologies coming down the road in the future that don't exist today or that we don't know about, that we can actually connect them to there. We actually have a pathway that we would allow us to put in a distributed antenna system that's fed over fiber, or some other technology that doesn't exist. We can actually connect that to this infrastructure without having to go back and run a new pair of fiber, which would probably be impossible in the real world. So this, like you said, there's 4 strands of fiber. We're only using one plan today, but we have capability both for spare as well as for future technologies that potentially are on the horizon. That's in this area. We're also, as I described, talking about long-haul DC power plants. So in the hotel MDF, the main computer facility, we would have a large UPS feeding that space, and in there we would have a DC power plant, which would be taking the AC power feeding the hotel and turning it into DC. And what we were doing is we're running that long distance. We're up-converting it to 190 volts, running it discretely to each guest room on a pair of copper strands, and then this box here is actually down converting that from 190 volts down to 48 volts. And the 48 volts will actually powers this unit with 75 watts of power, which is more than enough to actually power all the devices in the room, multiple access points and multiple phones for larger units or larger suites. And this is a very unique, this actually allows us to turn our IDF closets into a completely passive distribution point. So not only is the fiber optic being fed in a passive environment where it comes up and is distributed horizontally without any electronics, but also the power platform is being fed from a central location up through an IDF closet where it's being distributed horizontally with no electronics or no power, and then coming to the room where it's down converted and feeding the components. And we feel that this allows us a very flexible a solution which meets our needs for the short term and the long term. There's more than enough power to grow with, as well as allowing our IDF closets to remain passive without having to go and change electronics and components out in those locations. So we feel that this fiber to the room environment is our future going forward on new hotel development.